So what we have here is a synthetic division for those first three, and I've got the remainder circled in red. So you can use synthetic division to find a remainder. And what they want you to sort of look at here is said, well, after you did that, plug in 1 into that equation, and what do you get? 0. Plug in 3 into this equation, 3 times 27 minus 8 times 9 minus 3 minus 2, and what do you get? 4. And plug in negative 2 into this last equation, simplify it, and what do you get? Is 0. What do you notice about those answers? They're the same as your remainder. Now, sometimes, if the question says, what's the remainder? Sometimes it might be quicker to plug in a value. I think that's the case in the first one. Plugging in 1 into here is really easy to do. I just have 3 minus 2 minus 1. The mental math is relatively easy. Okay? In the last one, though, plugging in negative 2 into this, you'd have 2 times negative 2 to the power 4 minus negative 2 to the power 3. And all of those things have to be added together to get 0. It might actually be quicker to do the synthetic division. So when figuring out your remainder, you have two options. You can just plug in the value, because that will find your remainder, or you could still use synthetic division to find it out. The nice thing about synthetic division is not only do you know the remainder, but you know the rest of what the answer, the quotient, would be if you divided. So synthetic division tells you a little bit more. The remainder, by plugging in that value, just gives you the remainder. Now, the results of this is something called the remainder theorem. So you can highlight this on your next page. Remainder theorem. And all this is saying is that you can plug in your value, just like we did here. If I want to find the remainder when I'm dividing by x minus 3, I can plug in positive 3, the opposite sign, and whatever number I get is going to be my remainder. So we're going to get some questions where we really need to use this remainder theorem, and other questions where our synthetic division is going to be more than enough to figure it out. So let's look at example 1. Determine the remainder when 2x to the 4 minus 5x cubed minus 5x squared plus 5x plus 3 is divided by each binomial. So for A, what I'm going to do here for the answer is I'm going to split my page in half for A, and we're going to look at the two different methods. Using your remainder theorem, if I call this equation P of x, my remainder is going to equal P of 3. And P of 3 would be plugging in a 3 everywhere there's an x. So that would equal 2 times 3 to the 4 minus 5 times 3 cubed minus 5 times 3 squared plus 5 times 3 plus 3. And this is where the mental math starts. 3 to the 4, 81 times 2, 162. 3 cubed is 27. 27 times 5, 135. 9 times 5 minus 45 plus 15 plus 3. And now we have to figure out what this is going to be. I think it's 0. Synthetic division. What would our synthetic division look like in this case? So I'll do that in blue. We would write 2, negative 5, negative 5, 5, 3. We notice that they are in the right order and nothing is missing. So that's important. We would put a positive 3 outside here, bring our first number down, multiply, add, multiply, add, multiply, add, multiply. And we get a remainder of 0 as well. First thoughts. In this example, do you like the synthetic division or the remainder theorem better? synthetic division. I mean, with synthetic division, the biggest times table you needed to know was 3 times 2. Woo. Over here, the biggest thing you needed to know was like 81 times 2, or 3 times 3 times 3 times 3. So bigger numbers definitely on the left-hand side. Okay? And then in synthetic division, the biggest things you had to add, maybe 5 and negative 6. Over here, 162 minus 135. So mental math-wise, in this case for sure, it looks like the synthetic division is a lot easier. And that's usually the case whenever your number is something other than 1. Okay, so in both of these examples, in part B, again, if I keep things split up here, and on the left hand side, I plug in, say, if I want to find out P of negative 2, I'd plug that in. So I'd have 2 times negative 2 to the 4 minus 5 times negative 2 cubed minus 5, cheat a little bit, times negative 2 squared plus 5 times negative 2 plus 3. Negative 2 to the power 4 is 16. 16 times 2 is positive 32. Negative 8 times 5 is plus 40. 4 times 5 minus 20. Minus 10 plus 3. So we're going to get 52, 42, 45. And the synthetic division, what would it look like? 2, negative 5, negative 5, 5, 3. And outside, if we are dividing by x plus 2, we'd write a minus 2 outside. So bring down your 2, multiply, add, multiply, add, multiply, add. Did we get the same remainder? Oh, good. So either we made a mental math mistake twice, or we're good. I'm going to assume that we've got the right answer. This one, the synthetic division, shows that sometimes synthetic division can get to high numbers. But in this case, I still think that your synthetic division gave us a remainder quicker and nicer than plugging it in. Okay? But it's important to have both of these strategies because in mathematics, sometimes one method is easier than another, but there will be some cases where the other method is a better one to use. So both of them are important. Okay, so questions are 4A, 6A, 7, and 8.